Assalamu alaikum everyone, hope you're all going good, right? And well, welcome back to my channel, welcome back to the video, welcome back to the lecture. And once again back with you guys here in the lecture. So hope you're all going great and well. So in today's lecture we're gonna study the same things, physical and chemical changes, and I'm gonna upload it on the same day. So before that, if you have not liked, share, subscribe my channel, please do that. So, and if you're new, so don't forget to press the bell icon as well. And if you have any question on usual maths, and you can comment on any of my video, I'll go through it as soon as possible. So let's start our lecture without wasting any of our time. Bismillahirrahmanirrahim. Okay, so applications of chemical changes. We have done chemical and physical changes in the previous video. So in this video, we're gonna do applications of chemical changes. So as a result of chemical changes, new substances are formed, which I've already told you. We are living in the world of chemical changes now. Yeah, definitely you should know that there are different factories, there are different chemicals that are made, and there are different chemical reactions that are being done daily on daily basis. Millions of chemical reactions are being done daily. So chemical changes are taking place in our bodies now, in our vehicle and environment. So they have a very important role as well, like the all the medicines that we take, they're also chemical. So basically chemical changes basically are taking place in our bodies, in our vehicles, definitely in our environment. So they are present everywhere around us. Sometimes chemical changes form harmful substances. So it's not always that chemical changes are really useful for you. No, it's not like that. They are mostly harmful. Okay, now burning materials. Now, do you think that the ash is the only material produced by burning the paper? So gas is also produced. It's not like when you burn the ash, or if you think that the ash is only produced by burning the paper. No, it's not like that. Gas, there's a specific gas that is also produced. So what is the difference between heating an object or burning an object? So heating an object and burning an object. Now you should need to know this as well. Okay, so heating an object involves increasing its temperature by adding thermal energy, while burning is a chemical process where substance reacts rapidly with an oxidizer using usually oxygen, producing heat and light. Heating is a physical change and can often be reversed, while burning is a chemical change and usually is not reversible. So basically, this is the main change between them. Okay, so then we are having the next question, which is, what, 1 second. Do you think that when an object is burned, the process can be reversed? So wait, so the actual meaning of this question is that what do you say about when an object is burned, the process can be reversed? No. So basically, I think so. No, the burning of an object is generally considered as an irreversible process. So this is because burning involves a chemical reaction where new substance is formed, and these new substances cannot be easily converted back into original material. So you should know this, that we cannot convert it. Like there's some substances that cannot be converted back to their original form again. So original form again, so that's very hard. So most of these substances are not reversible, and mostly we cannot reverse it because that has a lot of complications, and becomes very hard. So yeah, that's the reason. Then coming towards the next question, can you think of everyday examples of wait can you think of other everyday examples of objects burning? So burning is also known as combustion, is a chemical reaction where a substance reacts rapidly with an oxidant, usually oxygen, that produces heat and light. Everyday example includes burning wood in a fire place, and natural gas in the stove, and fuel in a car engine. Matches and candles also demonstrate this process as does the lighting of fireworks. Okay, now burning. So here, when a material is burned, the change is chemical. You should know whenever it's burning of paper, burning of wood, burning of matchstick, burning of anything, you should know that it is a chemical substance. It forms a chemical substance. Okay, because composition is changed. Now new materials are produced when materials are burned. These are often hazardous. So basically, yeah, it's chemical. Now, combustion, use of hydrocarbons as fuel. So burning of fuels is another example of chemical chain. Now, burning of fuels, again I told you, burning of anything is an example of chemical chain. So again, here's the same thing. Fuel that we use to run our vehicles or factories consist of substances known as hydrocarbons. Now, you should know that all the fuel we use, it's used to run the vehicles and factories. It consists of substances. Now, there are some substances present inside it that are known as hydrocarbons. Now, what are hydrocarbons? A hydrocarbon is a compound consisting of only hydrogen and carbon atoms. Like, it only has the hydrogen and carbon items, no other item of oxygen, water, carbon dioxide, any other any other item does not consist, or that cannot come here. It's basically consisting, it's a compound that only consists of hydrogen and carbon items. Okay, so that's present in our vehicles and factories. Okay, then combustion. Combustion, the definition of combustion is: the combustion is a chemical reaction that occurs between the fuel. The fuel can be both petrol, oil, and oxygen that's present in the air, that produce oxides of carbon, water vapors, and energy, usually in form of heat and light. Now, here you are having basically word equation of it present inside it. Okay, so that means that fuel plus oxygen gives you carbon dioxide, water, and energy. Now, combustion or burning is combustion is also known as burning. Okay, so combustion or burning is a chemical reaction where a substance reacts rapidly with an oxidant, usually oxygen, to produce heat and light. So it's an aromatic reaction, meaning it releases energy and often results in the formation of oxidized products like carbon dioxide and water. Okay, so the main reactant are the fuel and oxidant, with oxygen being the most common oxidant. Okay, and the common products include heat and light and oxidized substance like carbon dioxide and water. So yeah, this is combustion. Now, what is complete combustion? We're having two types of combustion: complete combustion and incomplete combustion. So complete combustion, basically it occurs when a sufficient amount of oxygen is present. Now, when we are going to have a sufficient amount of oxygen, more amount of oxygen is going to occur. All the carbon atoms and hydrogen atoms react to form carbon dioxide and water. Now, you should know first of all that it occurs when a sufficient amount of oxygen, more oxygen, we want more oxygen. So when more oxygen is going to be present, and all the carbon atoms, all the hydrogen atoms, they are going to form carbon dioxide and hydrogen. So this is also a rule of it. Then in general, hydrocarbon plus oxygen, that gives you carbon dioxide plus water. So this is basically the formula of a complete combustion. Okay, then what we are having next. Okay, once again let me tell you what's complete combustion. So complete combustion is a chemical reaction where substance reacts with an oxidant, usually oxygen, to produce heat and light, with the products being primarily carbon dioxide or water. This process requires sufficient oxygen to ensure all the fuel is converted into these products. Okay, so next we're having is fire triangle. So fire triangle, in this you can see we're having oxygen, heat, and fuel. So this is a fire triangle: oxygen, we are having oxygen sided, heat, and fuel. So this is a fire triangle. So fuel is a substance that burns to release energy. So whenever fuel is burned, why it's burned? Because it to release energy. We burn the fuel to release energy. So each of these sides represent a key element for fire to occur. If one was removed, the triangle would collapse and the fire would go out. So if these three are very necessary, if one wants the fire to be launched or to be burned, so they need fuel, they need heat and oxygen. If one of these is not present, then the fire will go out, will not have the fire. Then we are having incomplete combustion. So if there is insufficient air for complete combustion, incomplete combustion takes place. When we are not having more oxygen in the environment, then incomplete combustion will take place. So hydrogen is still oxidized to water, but carbon monoxide forms instead of carbon dioxide. So this, what will happen, that hydrogen is going to be still oxidized to water, but what will happen, that carbon, instead of, when we were incomplete, we are having carbon dioxide, but in incomplete we're going to have carbon monoxide. Then carbon monoxide is a toxic gas, so accurate ventilation is important when burning fuel. So it's going to be toxic, so definitely then we need something else for it. In limited oxygen supply, then you will see fuel plus oxygen gives you carbon plus water, or it can be like carbon monoxide plus oxygen, that is not enough, gives you carbon monoxide, CO, and then water. So yeah, then again let me tell you about carbon mono sorry Let me tell you what incomplete combustion. So incomplete combustion occurs when fuel doesn't burn fully due to insufficient oxygen, resulting in the production of harmful byproducts like carbon monoxide, soot, and unburned fuel. This contrasts with different combustion, which produces only carbon dioxide and water. Okay, then what we're having is carbon hydrocarbons. So hydrocarbons basically are mostly obtained from crude oil, that is petroleum. So they mostly come from the petroleum. When hydrocarbons burned in the presence of oxygen, their chemical composition change. So you should know that whenever they are burnt, hydrocarbons, whenever they are burnt in the presence of oxygen, when oxygen is present, their chemical composition is going to change. So as a result of burning of hydrocarbons, a lot of heat is produced. So whenever there's going to be a result of hydrocarbons, what's going to have that a lot of heat is going to be produced. So people use heat for various purposes such as cooking, heating, movement, etc. So heat is very important for us, as well as it has some losses as well, but some it's useful as well. So basically a hydrocarbon is an organic compound that consisting of entirely of hydrogen and carbon. Hydrocarbons are example of group of 14 hydrates. Hydrocarbons are generally colorless and hypotic. Their odor is usually faint, and may be similar to that of gasoline or lighter fluid. Okay, so this is what hydrocarbon is. So use of heat, cooking, heating, movement. So these are the uses of heat. Now a harmful effect of burning fuel. Now here, complete combustion, that means complete burning. Incomplete combustion, that means burning. Then that means it's still burning but not a complete burning. Then complete combustion, so it releases unburned carbon particles. Now due to that causes asthma, respiratory diseases. So these are the harmful basically effects of burning fuel. Now then it also releases carbon dioxide that causes global warming, that's also very harmful for the environment. And that also releases sulfur oxide that causes acid rain, this is also very harmful. So these are the three harmful effects of complete combustion. Incomplete combustion releases carbon monoxide, now poisonous gas that can kill people. So it has a most harmful effect that it can kill people. Okay, so now it's these are the harmful effects of all of them. So now hopes you like the lecture. Bye bye, take care, Allah Hafiz.